Once again, we're combining functions, but this time they aren't a bunch of ordered pairs. This time they're algebraic functions. So f of x is x minus 2, g of x is x squared plus 4x minus 2, which I don't believe is factorable, so I'm not going to try to. And they ask us to do f plus g at minus 2. In other words, add up these two functions and then see what the value is when x is negative 2. There are two ways you can do this. There's the add the functions first, plug in minus 2 later, or plug in minus 2 right away and then add the functions. For this first example, I'm going to do both. I don't think I'll do both for every single example, but just in case you want to see. Here's f plus g. It's x minus 2, that's function f, plus x squared plus 4x minus 2. Now you can add those and collect like terms, and you'll get x squared plus 5x minus 4. And then we can sub in negative 2 as the value for x. So we get negative 2 squared plus 5 times negative 2 minus 4, which is what? 4 minus 10 minus 4 is negative 10, if I'm not mistaken. Your other option is take negative 2, plug it into each of these functions first. So minus 2 would be minus 4. Here we get minus 2 squared is 4, plus 4 times negative 2, that's 4 minus 8 is minus 4, minus another 2 is minus 6. Then add them together and your result is minus 10 again. So you can either combine the functions first or you can combine the functions after. It shouldn't make much difference. I think we normally do it this way, where we work out the sum or the difference first and then plug in the value at the end. That's the way that I'm going to stick with, but just know that if you prefer to plug in the values before, that is fine, that will work. So for this first one, as you just saw, we get a sum of minus 10, and so we can write f plus g at minus 2 equals minus 10. If you subtract them, you get x minus 2 minus x squared plus 4x minus 2. Now watch out, this negative distributes. It's going to affect all three of these terms, and if you forget that, all kinds of bad stuff will happen to you. Here we get x minus 2 minus x squared minus 4x plus 2, which cleans up to minus x squared minus 3x, I believe. And now they're asking us to plug minus 1 into that. So minus 1 squared minus 3 times minus 1, which is minus 1 plus 3 should be 2. So total of 2 for all that. F times g, multiplying the functions now, so x minus 2 times x squared plus 4x minus 2. Now I get to expand all this. X times x squared, x times 4x, x times minus 2, minus 2 times x squared, minus 2 times 4x, minus 2 times minus 2. Notice I'm stacking the terms with equal powers. It makes it really easy to add up at the end. This is not a big deal when you're doing a small expansion, but if you're doing a big nasty expansion, this is really helpful for keeping you organized and preventing mistakes. Okay, so there's what I get for the product of these two functions, and now they're saying, now once you got the product, put negative 3 into it. Negative 3 cubed is minus 27. Minus 3 squared is 9 times 2 is 18. Minus 10 times minus 3 is plus 30 plus 4. Minus 27 plus 18 is minus 9. Minus 9 plus 30 is 21. Plus 4 makes 25. That one should be 25. If you're doing the sub first thing, then you can check these results. You should be getting 25 also. F over g of 2, this means function f, x minus 2, divided by function g, x squared plus 4x minus 2. I guess that's all there is to the division. I am still reasonably sure that this denominator isn't factorable, so I'm not going to try to pull an x minus 2 out of it. Let's just put in 2 and see what we get. 2 minus 2. Oh, that happened fast. And then here we get 2 squared plus 4 times 2 minus 2. 0 over, well, it's some non-zero thing, so regardless, the result has to be 0. And finally, oh, they bring back domain to see if we still remember. State the domain of f over g of x. Well, there's two things we worry about when we're looking at domains, and those are there any roots in it? Because if there's square roots, their radicand better not be negative. That isn't a concern here. The other worry is, could our denominator be 0? Could x squared plus 4x minus 2 equals 0? Because if it could, we'd get a division by 0, and that would make our expression blow up. Well, I've been saying I don't think this is factorable, but that doesn't mean it doesn't have zeros. If we're going to be sure about that, we have to pull out, remember the quadratic formula? You've probably seen it before, and it's pleased to meet you again. We can use this to try to solve for x values where this expression equals 0. And remember, this equation uses the coefficients a, b, and c out of our equation. So in this case, a is the coefficient out here. A is 1. B is the coefficient on the middle term. B is 4. C is the constant coefficient. C is negative 2. So if we put all that into the quadratic formula, let's see what we get. X equals minus b plus or minus root b squared minus 4 times a times c all over 2 times a. Okay, please tell me we can clean that up. Minus 4 plus or minus, what do we get inside this root? 16 plus 8, we get root 24 all over 2. Now, if this radicand were negative, if we had root minus 6 or something like that, that would tell us that this radical is impossible, which would mean x equaling 0 is impossible, and then we'd have nothing to worry about. But here, root 24 is a perfectly reasonable number, and that means we are going to get solutions out of this. In fact, we get two of them. We get minus 4 plus root 24 over 2, and we get minus 4 minus root 24 all over 2. Both of those clean up. They clean up to, if you divide everything by 2, reduce the radicals and divide everything by 2, you get two values that aren't allowed. We get that x cannot be minus 2 plus root 6, and also x cannot be minus 2 minus root 6. So, bit of a battle. A little bit beside the point of the function algebra, but we wanted to remind you about the quadratic formula because it does come up sometimes. If a quadratic is in the denominator, then just like anything else, it is forbidden to be 0, and that means in this case there are two values we have to dodge.